This is a 2D liquid particle simulation that demonstrates fluid dynamics using simple physics. It shows how particles interact to create fluid-like behavior, such as flowing, settling, and reacting to pressure. Particles represent droplets of liquid. They attract and repel based on density. They slow down, viscosity, when moving past each other. They fall due to gravity and collide with boundaries. It is a simplified model. Real fluid physics is more complex, but this captures key behaviors in an easy-to-understand way. Key concepts in the simulation. Density measures how crowded particles are in an area. Each particle checks nearby particles within interaction radius. The closer particles are, the higher the density. High density particles push away to reduce crowding. Low density particles may clump together. Pressure strength controls how strongly particles repel when too crowded. High pressure strengths, more forceful separation. Lower pressure strengths, particles stay closer. Target density is the ideal density particles try to maintain. If actual density greater than target density, particles push apart. If actual density less than target density, particles may attract. Acts like a resting state for fluid compression. Viscosity strength, controls resistance to flow, how thick the fluid behaves. Particles try to match velocities with neighbors. Slows down fast-moving particles, speeds up slow ones. High viscosity behaves like honey, slow, sticky. Low viscosity behaves like water, fast, smooth. How it all works together. Particles move due to gravity and current velocity. Density is calculated for each particle based on neighbors. Pressure forces push particles apart if too dense. Viscosity smooths motion by equalizing velocities. Particles bounce off walls, creating containment. This program uses a very simple HTML structure. Just the essentials to hold the interactive demo together. The wrapper contains just two visible parts, a control panel header up top and the full screen canvas area below, where the liquid animation appears. The control panel contains 6 input elements to adjust the simulation parameters like particle count, size, and fluid properties. These controls are organized into 3 columns using Flexbox for a clean layout. Below this sits the canvas element, which takes up all remaining space and serves as the drawing surface where all the particles physics happens. For styling, the CSS is extremely minimal, just enough to make everything functional. It starts by resetting default browser margins and paddings to avoid layout quirks. The main wrapper stretches to fill the entire browser window, with the header and canvas stacking vertically. The header gets a light blue background and centers its controls, while the canvas container has a dark background to make the colorful particles stand out. That's really all there is to the styling. No fancy effects or complex layouts, keeping the focus entirely on the JavaScript simulation. One last thing. There is a function called handleControls that updates all the simulation parameters whenever an input element changes. Each input's ID matches a global variable name. To update them dynamically, I needed to get the input's ID, get its value, assign it to the corresponding global variable. This was the final part when the rest of the program was ready. So instead of refactoring simulation parameters as object properties or writing a long switch or if-else chain, I choose a lazy one-line eval solution. Programming gurus tell us that it is a bad practice. But this is tutorial project and I prioritize speed over clean code dogma. It saves me a lot of time. The link to the file location is in the description. I scroll through the code now. That's all for now. Have a nice one.